Welcome back, Math 30-2. Today we are looking at polynomial sinusoidal functions lesson 4. And this one we are finally getting into, breaking into sinusoidal functions, or sinusoidal functions. So, in order to do this first, we have to go back to trig. If we look at this, in the term sinusoidal, we have sine in there. Well, sine is one of our trig identities, so it has to do with trig. So most likely this has to do with trig. So we're going to first review a little bit of our trigonometry. So if I start off here, we have a positive angle. So every time I have an angle that's positive, we are going to start at our x-axis in the positive and go all the way there. So remember, we start in quadrant 1, start in quadrant 1 and we follow our degrees. We start from the x-axis in quadrant 1 and follow around. Okay? Now if it's negative, we go in the opposite direction. Okay? We are just going to have to go in the opposite direction if it's negative. So we go clockwise. If it's this one, we go counterclockwise. We always start on the x-axis in the positive. This one here, we go counterclockwise for positive and clockwise for negative. So here's an example to get through it. It says, sketch the angles and state the quadrant of which the angle terminates. So terminates means which quadrant does it end in, which quadrant is it in. So we want the angle 290. So that's positive. So I'm going to start here, and I have to go all the way around. Well, 270, and then a little bit more is 290. So it's going to go right here, and it's in quadrant 4. Okay, let's try the next one, negative 135. So we start here on our x-axis, trusty x-axis, but we must go, it's negative, we're going to have to go clockwise this time. And 135, well that's still 180, so I go this way, that's 90, whoop, and that's 80, so it's going to be somewhere in there. So that's in quadrant 3. Take a look at the next one, 750 degrees. Well, I look at this. 750 is a lot bigger than 360, isn't it? So I go once around, that's 360. Go a second time around, that is 720. I have to go a little bit more. So how do I do that? I go, this is subtract 720, which is 2 circles, which is equal to 30 degrees. So it's really 30 degrees from this x-axis. Okay, so that's what it is. So that's in quadrant 1. See how that goes? So we go a full 2 circles and then another 30 degrees. Okay? All right. So here is a little exploration for you. And this exploration is going to try and help you figure out about arcs and then the measure of a radian. So I'm just going to skip ahead to this part here. And it says, the measure of an angle in radians is really the length of the arc divided by the length of the radius. So when we're looking at radians, we're looking at this length. It's this distance. So it's the length of the arc divided by the radius. And that will give us this part here. And that's what helps us figure out what is a radian. So in your calculator before, you always had it in your graphing calculator, and it was always in radians or there, and you always have to switch to degrees. Now, we're actually going to find out when we use radians and why. Okay? Now, here we go. So I'm going to do this part here instead of using the graphing calculator, because this part here I think is a little bit important, and I'll help you through it. So one complete rotation of a circle is 360 degrees. All right? The arc length of one complete rotation is, so the radius, the arc length, the whole arc length is the radius goes around a total of the circumference, which is 2 pi r, which is the circumference. That's our formula for circumference. Okay? So the arc length to complete one is 2 pi multiplied by the radius, which is the circumference to go all the way around. So the ratio of arc length to radius is just 2 pi. That's it. Arc length divided by radius is 2 pi, and that is our rads. So 360 degrees is equal to how many radians? 2 pi. 2 pi radians. So now the next one says 1/2 of a rotation degrees is 180. The arc length for 1/2 of a rotation is, well, if it's 2 pi r the whole way around, then it's only going to be pi r halfway around the arc length. The radius multiplied by pi will give us the circumference of half a circle. So we're just using the circumference, what's the length, right? So pi multiplied by r, or 2 pi r divided by 2 is pi multiplied by r, gives us the circumference for half the circle. So the ratio is arc length divided by radius. Okay, so that's pi r divided by r. So I've got my r there. So my r's will end up canceling off. I forgot to finish that one, so we're just left with pi. So 180 degrees is equal to pi radians. Now, let's take a look at this. Pi is equal to 180 radians. So 1 radian is equal to, well, 1 radian, I'd have to divide this by pi to get 1. Pi divided by pi gives me 1. So I have to go 180 divided by pi to get my degrees. Now let's take a look at the second part. 180 degrees is equal to how many radians? Well, pi radians. So then 1 degree, to get 1 degree, I have to divide radians by 180. So I go pi over 180. Okay? To convert radians to degrees then, so to convert our radians to degrees, we have to multiply by 180 and divide by pi. In other words, we're getting rid of the pi form, and we're multiplied by 180 to put into degrees. This way here, it's like unit cancellation way. One's in terms of pi, the other one's in terms of degrees. So you want to get rid of the terms of pi, divide by pi. Then multiply by degrees, now it's in terms of degrees. This one here, well, it's the opposite. It's pi over 180, because we want to go from degrees to radians. So we want to get rid of degrees, we divide by degrees. And we want in radians, we multiply by pi, because radians are in pi's. That's it. So this is, in general, your formula for converting. That's something you should kind of know. Or you could just do it on your calculator, which we'll do later. So here we go. It says, convert from degrees to radians. So this one's in degrees. We want to convert to radians. What am I going to do? I'm going to divide it by 180 and then multiply by pi. Okay? What does that give me? 180, 270 divided by 180, and once in exact terms of pi, is the same as 3 over 2, which is pi. So 3 pi over 2. Okay? Now let's take a look at this next one here. If I have 315 degrees, now I must, once again, divide by 180, because we want to convert it into terms of pi, which is in radians. Okay, so then I multiply by pi. Now, I'm not 100% sure what 315 divided by 180 is. I think it's going to be 7 over 4. I'm not sure. So I'm just going to go quickly on my calculator. 315 divided by 180. And, oops, 315 divided by 180. And I'm going to multiply it. And that is the same as 7 over 4. So I was right. So we have 7 over 4 pi. Maybe even in terms of pi. Okay? Next question here says, convert the following from degrees to radians. Okay, so 70 degrees. And it wants to the nearest tenth. So I have to divide that by 180. So I'm going to put that in. 70 divided by 180 gives me that. Okay? Now I'm going to multiply that by pi. I get 1.2 to the nearest tenth. So we multiply that by pi, which gives me 1.2 rads. Okay? Let's try the next one, 205. So I divide this by 180 because it's in degrees. We want to convert it into terms of pi, which is in rads. So we multiply them by pi. So let's try that out. We go 205 divided by 180. And then I'm going to multiply by that by pi. And I'm going to get, is that it? 205, 180? 3.6. Okay? So I get 3.6 rads. Alright, that makes sense because it's just over half a circle, which is pi, and pi is 3.14. Makes sense. Yeah. Okay? Now let's take a look at the next one. It says, convert the following from radians to degrees. So this one here, I have to divide this by pi. And then I'm going to multiply by 180. So if I go pi over 4 divided by pi, that's the same thing as 1 over 4. And then I multiply that by 180. 180 divided by 4 is going to give me a total of 45 degrees. Okay? So I first divide by pi, then I multiply by 180. Or I could say I multiply this by 180 over pi. Okay? So 1 in degrees, and I'm getting rid of my pi's. Let's take a look at the next one, 7 over 3. Well, that's the same thing as I'm multiplying by 180, because I'm 1 degrees, and I have to get rid of my radians. So let's get rid of my pi terms. Well, that's going to be 7. These pi's cancel off, just like they did there. So I have 7 times 180 divided by 3. First I'm going to divide that by 3, which would give me 60. 60 times 7 is 420 degrees. That's it. Okay? The next one says, convert the following from radians to degrees to the nearest tenth. Okay, so we want degrees to the nearest tenth. So if I have 1.57 radians, well, that's in terms of pi. So I have to multiply by 180, divide by pi. We'll try and get rid of the pi's. So I go 1.57, multiply by 180, and then I'm going to divide by. And that gives me 89.95, which is 90.0. Okay, let's try the next one. We have 1.4 multiplied by 180, and then we divide by, and I'm going to get 80.2 degrees. Okay? Now this next part here is telling you how to use the calculator and to convert from degrees and radians in your calculator. Okay, I expect you to read that. Most of you know how to switch to degrees. Now you're going to actually sometimes switch back to radians. So here we go. Here is our first example with using the trigonometry ratios in the calculator. So the first one says we want cos 280. Now here's the hint. If it's in degrees, our answer should be in degrees. So I'm going to double check, make sure my mode is in degrees. Go over here, and I look at that, and yes, my mode is in degrees. So I'm going to continue this. And we are looking at 280. So we go cos 280, push enter, and I end up getting 0.17. So I get 0.17. I think to the nearest decimal place, to 4 decimal places, 1736. So it wants to 4 decimal places, 1736. Next one is sine pi over 6. Pi over 6. We know there's a pi in there. That means it's most likely in radians. So I'm going to have to go to my mode, switch it to radians, and I want sine pi, 7 divided by 6. And I'm going to get negative 0.5. Okay? The next one here we look at is cos 10 pi over 3. 10 pi over 3? That's still in radians. We have a pi. Okay, so let's go. Cos 10. And I end up getting negative 0.5 again. Okay? And now let's take a look at my last one, which is sine 90. Well, 90 degrees, that's in degrees obviously, so I'm going to have to go to my mode and put it back into degrees. And I have sine 90, which gives me 1. If you like doing everything in one or the other instead of switching your modes, you could just do like what we did earlier and convert this 280 into pi, or you could convert this here, 7 pi over 6, into degrees. So you can convert your degrees into radians or your radians into degrees to calculate. It's up to you which way you want to do. Okay? And let's take a look at our next one. So we have one more investment here, and this is about graphing. Okay? So I'll let you try and do this. This is a very good investigation to do. It's about graphing what happens and seeing what happens when we graph. Now, if we were going to go sine of 0 degrees, well, just type in everything here. I'll help you with this first one. So we want sine 0 is equal to 0. Okay? Another way of thinking of it, sine is normally your y value. I'll find out. Sine 0 is 0. You have 0 y value. The next one, we want 30 degrees. So let's see, sine 30. Gives me 0.5. Okay, so we have 0.5. Sine 60 degrees. It gives me 0.866. And I'm going to keep on doing that. So this is 1. Now this one here, 120, is going to give me 0.8, this is 1, sorry, 120 is going to give me 0.866. Oh, yep, 0.866. And this here is going to give me 0.5. And then 180 is going to end up giving me 0. Okay? Now if I continue this, we have 210. 210, just punch into the calculator, so I'm just going to fill out everything. If we did 210, that's going to be negative 0.5. 240 is going to be negative 0.866. 270 is going to be negative 1. Then we go negative 0.866, and then negative 0.5, and then 0. So if I did this, we're going to go, we know, at 30 degrees, so that's 1/3, it is at 0.5. And 0.5 is, which is right, 1, 2, 3, 4, 5. So 0.5 is right there, I believe. Okay, and then we at 90 degrees we're at 1. Then we go back down, we're at 0.5. And we're there. Then we continue this at 2, and then at 30 degrees from there we're at negative 0.5. 270 we're at negative 1, right? And then at where are we? 270. Then we're at negative 0.5 at 330. Okay. Oopsie, I'm a bit off there. 330, negative 0.5 is going to be right there. And then we have, because each of these are counted by 30s. Each of these are counted by 30s. That's how I'm able to do this so fast. And 360, 0. So my graph is going to look something like this. And the pattern repeats. Because then after this, we start again. So our graph looks like that. It's a nice little wave. Okay? If you were to graph this, sine x in your calculator, just put in sine x, go sine, where are we? Sine x. We're going to get something like that, but first I have to change my window. So if I'm in degrees, then my window, it's in degrees, so I have to go to 360, or I'm going to go bigger. My x max, max min I'm going to say is 250, or I'm going to say 360. And my max, because I want 2 degrees the other way, is going to be 720. That's 2 full circles. My scale, I'm going to count by maybe 45s. Okay? So every 45 degrees it counts. My y min is going to be, I'm going to say 2. Oops, negative 2. And my y max is positive 2. Because the maximum height we could ever have is 1. And my y scale is going to be by 1. So I graph it. And there's how my graph looks. So it's a nice little thing, kind of what we have here. So anytime we have a wave, this might do have sound and stuff like that, these are sinusoidal functions. Okay, sinusoidal functions. Now, it says copy the graph and complete the graph. So here we go. So state the following function for sine x, where x is defined on the set of any real numbers. So what is the domain? If I look at this, this graph goes forever that way, like right here, it goes forever this way and forever that way. So my domain is x is an element of all real numbers. Okay? Move this all the way. Okay? So we get x is an element of all real numbers. So now it wants to know, what is my range? Well, what is my range of this? Well, we're going to look at y, such that, and then if I look at this, we are from 1 to -1, such that y, oops, we have, I'm going to put my values here, like that, because it's in between y, we have -1 must be greater than -1, but less than 1. And y is an element of all real numbers. This is the fancy way of writing it out. Okay? Now we want to know my x-intercepts. Well, my x-intercepts are, we have 180, 360, and then I'm going to guess the next one is going to be 270, or 360, 180, 360, then 540 is probably going to be my next one. So it's every time 180. So it is going to be 0, 180, 360, and it goes on and on forever. So it's 180 multiplied by n, where n is an integer, really. And my y-intercept is at 0. Okay? So here we go. Here's our class example to graph this. It says, a student was asked to reproduce the graph on the previous page in radians. Write down on the graphing calculator student window should be. So now it's in radians. So we have to change our mode in our graph, our mode, to radians, right? Now our window can't be this because this is in degrees. So if I went negative that, so I'm going to go -2 pi is every 360. So I'm going to have 2 second pi. Whoops. Okay, and my max, well, I have 2 360s, so that's 2 pi. So that's, whoops. 1 second here. So that's 2 pi, so that is the same as 4 pi, because 2 times 2 is 2, 4 pi. And now my scale, I'm going to say it was 45. I'm going to say it's pi divided by 4. Okay? My y min, y's are going to be the same, so I'm going to graph it. And look at that. I have essentially the exact same graph. Interesting. Okay? So if I'm going to graph this, every pi is 180 degrees. So that's where we hit. And I have 2 pi. It's going to hit there again. So I'm going to go all the way up, and right in between, we're at 1. And then right in the middle, we're going to be at -1. So my graph is going to kind of look like this. Right? That's it. And we're at half right in between here, so really I was a bit off. That should be half, so it should look like that. So it should be more rounded. And that's how we do that. Okay? So the same idea here. What is the domain? Well, domain, x is an element of all real numbers. What is my range? Well, my range is between, y must be, is in between, I'm just going to put -1 and 1. So in radians, it doesn't change, but my x-intercepts change. My y-intercept's still 0, but my x-intercepts change. Now they're 0, pi, because we are no longer in degrees. We're in pi, and we have 2 pi, and then I'm going to say 3 pi. So it's all of our pi's, right? It's how many full numbers of pi's. And that's it. Okay? So it says write down the window. I kind of showed you in here, so you could just use that and copy what my calculator had. And that is everything. So hopefully you understand a little bit the introduction to sinusoidal functions.